Triangles and some practical applications. Recall sine rule. A over sine A equals to B over sine B equals to C over sine C. In figure 1, ABC, that triangle, capital A stands for angle, small letter A stands for size. The same thing for B, capital B, angle, the small b there is the side. Sine rule is used when one side and two angles are initially given, or two sides and an angle not included are initially given. While the cosine rule, a square equals to b square plus c square minus 2bc equals a, or b square equals to a square plus c square minus 2ac equals b, or c square equals to a square plus b square minus 2ab equals c. The cosine rule may be used only when two sides and the included angle are initially given, or three sides and initial angle given. Let's look at an example. Example 1. In a triangle XYZ, angle X is 51 degree, angle Y is 67 degree, and YZ, the side YZ is given as 15.2 centimeter. Solve the triangle and find its area. Solution. In the diagram, we have capital Y to be 67, angle X to be 51, and side YZ, which is small x, to be 15.2 centimeter. Angle Z is not known, but we can get that since we know the two angle Z and Y. We know those two angles, we can get capital Z. Angle Z is 180 minus 51 plus 67. Since sum of angles of a triangle sum to 180 degree, then applying the sine rule, 15.2 ax over capital X sine capital X, that is 15.2 over sine 51 degree, equals to y over sine capital Y. Y, small y over sine 67 degree. We don't know small y, so which is same thing as z over sine capital Z. So we can use any of the two. 15.2 over sine 51 degree equals to y over sine 67. This implies that y equals to 15.2 times 67 degree over sine 51, and that gives 18.00 centimeter, which is xz. For z, using the second part, 15.2 over sine 51 degree equals to z over sine 62. Z equals to 15.2 times sine 62 divided by sine 51 degree, and that gives 17.27 centimeter. Now let's look at the area. Recall the area of a triangle is given by A equals to half base times perpendicular height, or which is half AB sine C, or half AC sine B, or half BC sine A, or using Euler's formula, the area is root x into x minus A, x minus B, x minus C, where x is A plus B plus C over 2. In the area of that triangle XYZ is given as half times xy sine Z, or half xz times sine y, and that gives half into 15.2 times 18 times sine 62, which is 120.8. So you can also use half 15.2 times 17.27 times sine 67, which is the same thing as 120.8 centimeter squared. Now, example 2. Solve triangle DEF and find its area, given that EF is 35 millimeter, D is 25 millimeter, and angle E is 64 degree. So in that diagram, applying this cosine rule, E square equals to D square plus F square minus 2DF cos E. So we know D to be 35, F to be 25, substituting 35 squared, E square equals to 35 squared plus 25 squared minus 2 into 35 times 25 cos 65 degree. And solving that, we have our E to the square root of 1083, which is 32.91 millimeter. Applying the sine rule, 32.91, which is small e over sine capital E, which is 64, small e over sine capital E equals to 25 over sine f, small f over sine f. So solving for sine f, making sine f the subject of the formula, sine f is 25 times sine 64 over 32.91, and angle f is 43 degree or 4 minutes. Now sine could also be, that angle could also be positive in the second quadrant, that is 180 minus 43 43 degree 4 minutes, which is 136 degree 56 minutes. But we cannot use 136 degree 56 minutes. The reason being that if you add it to 64 degrees, it will be more than 180. So we'll pick 43 degree 4 minutes as our answer. Angle F is 43 degree 4 minutes. So angle D, since we know E and F, angle D will be 180 minus 64 plus 43 degree 4 minutes, and that gives 72 degree 56 minutes. The area of triangle DEF is half into DF sine E, which is half into 35 multiplied by 25 sine 64, which is 393.2 millimeters square. We will also use the Euros formula, x into s minus ds minus es minus f, where our x is d plus e plus f over 2. That is the sides divided by 2, all the sides, the sum of all the sides divided by 2. Now, let's look at another application. A man leaves a point. Example 3. A man leaves a point walking at 65.5 km per hour, that's the speed, in the direction of E 20 degree north. The bearing of that is similar to 70 degree. A cyclist leaves the same point at the same time in the direction E 40 degree south. The bearing of that is equivalent to 130 degree. Traveling at a constant speed, find the average speed of the cyclist of the walk if the walker and cyclist are 80 km apart after 5 hours. Now the solution. After 5 hours, the walker has traveled 5 times 6.5. That is distance is speed times time, which is 32.5 km. Applying sine rule, that's the diagram there. Applying sine rule, 80 over sine 60, that is the side small a over sine capital A. Sine capital A will be 40 plus 20 degree, that's 60 degree, equals to small c, which is 32.5 divided by sine capital C. So making sine C the subject of the formula, I have 32.5 times sine 60 degree divided by 80. So C is arc sine 0.3518, and that gives 20.60 degree, or 180 minus that gives 159.4 degree. So, but this is not possible. If you sum 60 plus 159, it will be more than 180. So we'll pick 20.60 degree as our angle. So angle B, since we know C and A is 60, C is given as 20.